talking about how crappy our programmers are. Like, YouTube is a crappy, and just really stupid people. Like, here's an example, right? I'm streaming live. My phone has the ability to make a light on my face because Android has that built-in camera app. But the YouTube app, well, first of all, YouTube forces you to use the YouTube app. They don't allow competition for a better app, right? So you have to use the YouTube app if you want to use the YouTube database. And I think that's a mistake because the YouTube app is very extremely poorly programmed. And here's an example. As I'm just trying to make a live stream, the option to use the camera is not there. The option to use the camera with the flashlight is not there. Forgive me, I have to get up early in the morning to drive trucks, so my brain is, working all that great. Why? Well, I don't know. Google never hired me. Microsoft never hired me. The only question Microsoft asked me was the easiest math question, and I solved it instantly. And they did not hire me. It was not based on merit. It was not based on, was I smart enough to work for the company? It's based on people's opinions. You know, I don't know. Maybe you have to be like a Democrat to be like a programmer or something in this world. Silicon Valley. I don't know. So, but I tried working with them too. And I tried working with under a professor. And you guys know my story with that. But, you know, uh, instead of paying attention to what I did and whether I was actually getting the job done, you must have been paying attention to what other people felt about me, thought about me. So, um, yeah, it's that. Um, um, so I wanted to start this video, this live stream, to talk about uh, a video that I saw on YouTube. And that video was one about an injection of malware into a game file or a game. And I thought it was funny that they were talking about how sophisticated, it was to put in this injection with the assembly or whatever, with the DLL. I thought it was funny because security is one of the things one of the applications of my idea comes to um, basically when it comes to uh, that when it comes to restructuring everything in that logic system way of doing things instead of the kind of the traditional Linux way, where quote unquote everything is a file. And obviously, they made a Phantom OS or whatever where everything is an object or whatever. Cool, I don't care, right? That's great, but uh, I care about the structure of the files themselves, the structure of the data and the information, right? If you have a train complete system, there's this idea that they call in like C# reflection, where you basically are running code that is originally treated as data in the code. What's going on? I'm just doing a truck delivery. So that's what I do. but I want to talk because I don't like to drive. I like to think. Uh, and I also can't tell what's going on with anyone watching unless they actually put it in the chat. So you kind of got to assert yourself a little bit. That needs to be said, I guess, because the amount of information I have about subscribers is essentially based on whatever YouTube shows me. In fact, I don't even know how their algorithm presents my videos to people, so it's hard to figure that stuff out. Um, Look, there are going to be security flaws anytime you have reflection like that. If something's given access, right, to more than what it needs access to, every function should be considered potentially hazardous in some sense. Is what my point is. Hi, Martha. Hi, 3 times. I like that. Help wake me up this morning. Um, but thankfully, I might be done with my work, at 9 o'clock in the morning. So that would be nice. Look, we can solve security, right? Like Elon Musk wants to solve traffic with tunnels, and people will call him crazy. I'm actually presenting how do you solve security issues at their core. Well, every function, you know what a Turing machine is, right? We also have Lambda calculus. If you have something that is data, right, you treat it like that, right? So if you know that it's say you have like an integer that's a certain number of bits long, right? The only thing you can ultimately assume about that integer is what you've proven about it. So if we haven't proven anything specific about it, then all we know about it is its length. So when it comes to data that can be treated as a program, we can assume that it can be anything, right? It could be code that says, hey, open up this specific email with this specific password and all sorts of stuff like that. Now, another thing that we can sometimes assume is that malware data probably doesn't have certain. We can assume that it doesn't have, like, say, our certain private keys or passwords. So, because if they did, we would give access potentially to something, right? So sometimes we can assume that, hey, if we download this data, we're assuming that the initial state, it doesn't have a private key or password. So there's all these things you can think of conceptually in an attempt to, like, target data in your mind as, oh, is this hazardous or not? Is this malware or not? But there's another way to look at it. And it doesn't really assume anything about the data. It more focuses on how you treat the data. And that it's kind of like the virtual machine idea, except virtual machines, the problem with them is that they act like you need to run this entire program to emulate a machine. And I assert that that's not true. You don't actually need to run a virtual machine to test the things that I'm interested in. Sorry, I should say, separate the things I'm interested in, separate. Because in that video, they ran a virtual machine to test to see if it was malware. But if you always ran everything in a virtual machine, well, then, that's now what does it matter what's malware and what's not? Now, as soon as I say that, somebody who doesn't understand that I'm constructing concepts with theory, they're going to assume that these pre-existing concepts of what a virtual machine is, and they'll think, no, that's inefficient. How could you run a million virtual machines on one little computer? Well, because they're not going to actually be these virtual machine software instances. They're actually going to be they're actually just going to be pure functions. So the way that I'm constructing my operating system is that it doesn't care whether any application is malware. It doesn't care. Because none of the applications will be given access to anything that it doesn't have permission to have access to. Just like any app on the App Store. And if an application needs to use something else like photos, they already give you the option to select which photos you want this app to be able to see. And that's a sign of what's coming, right? That's actually how that's a more sophisticated filtering of the data that you're giving the app access to. The problem is that that's scratching the surface. Because that's just thinking about data in like a layer, in like just a single, like a ring zero thought process of data, right? This is very unsophisticated. Data is a very, very crude way of thinking about these ideas. The ideas that I'm asserting are we should be thinking about them in terms of types and category theory, how they're represented, right? Traditionally, they would say, hey, let's treat everything like an object. Let's do everything like Lisp. Everything's an S expression. Okay. In this case, I'm saying, no, we should treat everything as though it is. We should actually be operating everything under a sophisticated enough logic system to handle what we want to do. So we have to stick with something like calculus and inductive constructions. Treat everything as though it's something in that system. Right? Now, it doesn't matter. Let's say you have two functions in that system. Well, now you apply one function to the other. Formally, it's not, I have this data that when you put it into a machine, it runs, this assembly, and I think of it as a function, and then I feed in this other one as data. Because when you do that, you don't know how that works. But if you know how you're applying them together already, because it's predefined in the logic system that you're using, now your data is no longer the master. Your logic system is the master. It's telling the data what to do. It's telling any programs you want to run are not telling your machine what to do. You're telling, you're looking at the program and the machine. Your logic system is looking at the program and the machine, and it's deciding what to do. It doesn't, the program doesn't have control over anything. It's just laid bare for what it is. Right? It doesn't mean you necessarily understand it, but you're in control of it because you're only operating on it what you want to operate on. So let's say there's a function in there, right? Let's say there's a lambda calculus expression. What is that going to do? Lambda calculus is Turing complete. So let's say you represent malware in lambda calculus. Well, what is that going to do? Take over your machine? Only if you give it access. If you have an input and output that you give it access to, where for some reason expression can actually access a network or access uh, sensitive data, then it's just an expression. Am I making sense? So, is this making any sense to you guys? So it doesn't matter. It doesn't matter, guys. If you have malware on your if this expression until you're actually giving it access to something important. So you might as well treat it itself like it's an expression. I don't know, guys. Treat it like it's an expression, and that's all it has access to. It's just being itself. So now you're running programs, right? You're applying lambda expressions to each other. Maybe you care sometimes, right? And let's say you do care, right? You're like, well, I want to run this in a way that has access to my photos and data, my social media, or whatever. But I don't know what it does. I don't really trust it. I trust it enough, I think, because of where I got it from. But I want to know, that I can trust me. Well, see, now you're defining sort of the boundaries of this problem. You have the ability to observe what this thing is doing in its inputs and its outputs. It's an unknown computation. So if you haven't proven anything about what the computation is doing, well, you can at least prove what the inputs and the outputs are, right? And since you're in control, since your logic system is in control, this is a formal, this is a formally shown statement. This isn't just, well, we think we're watching this malware, but we accidentally, we didn't realize it was actually copying itself, into the assembly or whatever. The thing is, I could make a CPU that has malware hardware that checks for certain expressions, right? It looks for certain patterns in the data, and then suddenly it switches and changes its behavior because it's built in that deep, right? Same thing with a compiler. It can be built into something like that. But if you know that you're treating this as an expression, if you're treating an integer as an integer, it doesn't matter what the integer is. You cannot come up with a malware integer because you're treating it as only an integer. That's it. You cannot come up with a malware lambda calculus expression if you're treating it like it's that. Right? Let's say I handed you unknown executable. And it literally could be, it can be programmed by anyone to do anything you can imagine. Probably the only thing you would want to assume about it is it doesn't have maybe certain private keys or something. That's it. You don't need to run an entire thing that they call a virtual machine every time, every little. What you need is you need to be able to run a virtual machine for literally every subroutine in that program. And the way you do that, well, the functional programmers will they already have their way their thing they call pure functions. They're not full operating systems being simulated on your computer. All they are is just a definition of context. You don't have access to just write or read from any variable or any piece of memory just because it's there. Instead, it's treated like data. It's treated formally. It's treated formally as a function, mathematically. And when you do that, you have to know what it is because you're the one in control of defining it. It doesn't matter if somebody writes malware and I take their program and I say, oh, that's not an exe. Ha, that's not an exe, that's just a PNG file. And I draw it on the screen. Guess what? Their malware no longer functions because I'm looking at their malware as though it's an image instead of a program. Well, it's the same thing with programs. Instead of treating a program like it's let this thing go. Let this little animal loose in my house to do whatever it wants. Instead, the animal is on a leash. The animal is inside of a cage. It doesn't matter if the animal wants to attack you if it's inside the cage. It doesn't matter if the animal wants to go exploring in your house if it's on a leash. It can't happen because you've restricted what you're allowing this thing to be. So I'm watching this video. It's just funny because yes, somebody injected DLL files that were malware. But why were they able to do that? It's not It's not the fault of somebody who downloaded the DLL file. It's the fault of the operating systems that were being pushed to use that don't discriminate how they actually work. They don't, as soon as they did not start changing fundamentally how operating systems work, back Windows Vista, Windows 7, that's when Microsoft gets an F. Microsoft gets an F. They fail. They don't get a B, they don't get a C, they don't get a D minus. As soon as they make operating systems like Windows Vista and Windows 7, and they're so obsessed with backwards compatibility that they reject the entire future of software, they get an F. Why? They rejected everything about the future of software. By saying, nope, we're not going to redesign anything fundamental. We're not going to redesign anything fundamental. We're going to reject the future of software. Microsoft, when they made Windows Vista, they get an F for fail. Because there's nothing good about taking pre-existing systems at the time that they need to be updated to an entirely new type of system that mathematicians are the ones right there available to figure out. Mathematicians are there to tell you this is how you do it, and you don't listen to any of them. They get an F. They fail because they have zero interest in the future of software. There's nothing good about that. There's nothing good about still having DLLs that inject some sort of hidden functionality onto someone's personal computer. There's nothing acceptable about that existing when we have calculus of inductive constructions papers written in the 1980s. When we have Lisp definition research papers written in the 1950s. When we have types, type theory. When we have lambda calculus, which represents computation, written in 1936. We should not be having to convince these programmers and IT specialists to running virtual machines that act as expensive full program operating systems, and then not even just to run your program, but to test the program to see if it has malware. You shouldn't be doing things at this bare bones data level still. Now, Quake 3, whatever they did, fast inverse square root. All right, I'm gonna try to prove myself wrong here because I'm being harsh, right? But I'm gonna try to prove myself wrong. Quake 3, inverse square root, right? They try to make a algorithm that runs quickly, right? As C. Okay, I'm gonna try to prove myself wrong, but here's the kicker. Right, Tim. It's got to be wrong because people are still coming up with more efficient, more practical ways to solve low-level problems. You can't abstract away all that stuff. They still need access to all the low-level stuff. We still need to be able to trust developers, when they make software with their little tiny low-level functions, because they might have made something better. Well, let's freeze that thought for a second. Maybe, maybe they've made something better, but does that mean that we can't still treat it formally? So, think about this for a second. Somebody writes a faster inverse square root. Well, what is that? It's a function that has a specific input and a specific output. And it's also more complicated than just the input and the output. Because, right, I don't want to. It's a lie to just say, well, it's a black box. There's a lie in the whole black box theory, because it's also about the computation that it's doing. So you can also you can think of it at least by analogy, like it's a lambda expression, because it's a computable function. So it's actually taking up a certain amount of like memory and time. But when you take all that into account, it's still something that you can package up for a type-based operating system. So you can say, hey, look, this function it's using this amount of memory, it's using this much computation power, this much time, and it wants this type of input and this type of output. Maybe the output's a stream, okay? But when you take all those into it, when you take all that information, you're still defining the boundaries of this function. So does that mean that if somebody tried to insert malware into, say, yeah, this is going to be an exercise for you guys. Tell me how do you deal with it if somebody tried to insert some sort of malware into specifically something like the inverse square root for Quake 3? How would you do it? Tell me how you would do that. How would you treat a function like inverse square root, fast inverse square root or whatever it was, for a quick that game? If you don't know what the function's really doing for sure, you can't prove what it's doing, how do you treat this function? I mean, if you know what its inputs and outputs are, you know what its boundaries are, you know these things, then can't you not only try to set these boundaries every time you invoke the function, but can't you also do something a little more sophisticated than that? I mean, think about it this way. I can break apart a lambda calculus expression, and I can deal with it in a different way than the typical reduction way, right? I can deal with it any way that I want. But that includes trying to use the expression efficiently for what it does and encapsulate it in a way that keeps everything else safe. Think about that. Wow. I don't know why people are cutting in front of me. It's not like I have a job. Maybe I should go talk to him. Some people they sometimes it's wise to hold back. You want to go hurt someone. You want to go yell at someone. Sometimes it's just easier in life if you just hold back and do what Craig does. Make something that lets you beat them in the end. You don't got to fight them when they're yelling in your face, they're cutting in the line in front of you. Just make sure that you win in the end. That's what you got. You got to win in the end. Thanks for watching my live stream, guys. Sorry that I had to yell about Microsoft or whatever. It's not just them. There's a lot of companies that really get under my skin. I was so angry when I first was using I think it was like just a McDonald's app or something. I was at my university and I was just off the rails, and I was so angry because I was confused. Why did McDonald's have a crap? Why did they have an app? They have all this money, right? They could hire anyone. They could have hired me to just develop an app that makes sense. And doesn't have bugs, and it just works. I mean, I would make an app like that for myself without money. But when you're serving millions of customers and you have billions of dollars, why can't you do what one man can do who's only making something for himself in his off time without any money? Does that make sense? I don't know. I guess maybe I'm just not making any sense. I mean, that's basically what McDonald's does, Apple does, all these big companies. They all make something trashier with billions of dollars and 1,000 engineers. All right, I'll see you guys later.